Hello again, everyone. So last time we ended up implementing this function that is called add edges from, which is essentially a function that was part of the network class. Let me switch back here, which is this function here, add edges from, and it used to take a list, and this list has been added to the graph one edge at a time. And then we ended up visualizing the graph after it has been populated by the new list here. But what we discussed last time, we said is that this list here was essentially hard coded. Yes, we managed to have a mechanism that can create a function, create a graph that can be populated from a list, from a data structure that holds possibly millions of edges or nodes. But for the time being, what we looked at here is essentially something that is hard coded. So we said how good this is, and I promised you, I said, come back for the next lecture, and I'm going to show you how we can work with Twitter data to be able to create a network from the Twitter data, and then we can basically use this large scale function to add edges to the graph that we're creating, so we can see a much more complex network that is not exactly hard coded like we did here. So if I give you a Twitter data that looks like this, and this is actually a screenshot from a file that we're going to be working with today. The file here has each has a bunch of lines, a set of tweets. Each tweet is comprised of three different components: a timestamp, and the original person who tweeted the actual tweet, and the actual tweet by itself. So three components here, and as you can see, the key separator here is this bar that separates the three components. So there is a timestamp and the person who tweeted and the actual tweet. There's a timestamp, the person who tweeted, and the actual tweet. So what we want to do now is we want to construct a network of the person who tweeted, and if this person mentioned another person, whether this person was being mentioned as a reply or as a retweet or as a mention with the intention of mentioning somebody, even if you're not replying to them or retweeting them. So we want to construct a network of these pairs. So that would be like my source, and that would be my target. So how do we get started on this? Well, to get started on this, I created a small file here. It's probably as you can see, it's a really small file from real Twitter data that I gathered using the Twitter streaming API. Let me give you a little appreciation here. So this is a script that I've written in Neo4j, which is a Java code, the Java object oriented. So it's basically collecting the tweets here in real time. So what I'm showing you in the in this screen here on the Jupyter Notebook is just a small file from the streaming tweets that I'm collecting in real time, as you saw. So what we care about here is this file here. It's just a small data set, and we want to capture the interaction between a person who mentions another person or replies to another person. As you can see here is a person who mentions two people here. So how do we do this? Let me show you. Well, first of all, we need to start working with the data, and being able to work with the data, the most important thing is to actually read it from the file. How do we do this in Python? Well, in Python, we have this wonderful built-in function that's called open, and this function actually takes the file name, and since we are reading the file in the same in the same workspace, so I have not specified the directory because both the Jupyter Notebook and the file are in the same spot. So I'm not specifying a directory here, which means both of them are in the same spot. So this function is going to give me a file handle like that. And this file handle will be loaded once I execute it. It will be loaded with all the lines that I have within this handle here. And let me show you. So now we did not have any errors. If I read maybe like the first line or something like that, or actually what I can do, let me show you what we can do. We can actually grab this file handle. We can read all the lines together like that. And by doing this, this is going to return a list of all the lines. So if I just specify that I want the first element of that list, then this is going to give me the first line of this file. And to prove it to you here, let me take a look. This is my file here, so I'm going to grab that. So this is coming from the file, and I'm switching back here. So this is what I'm reading from the file, like that. And it's exactly what you're looking at here at the bottom is exactly what we read here. So this is really good. All right. So now what I want to do is really what I want is to start working with these list of lines, and I wanna separate them. I want to read them one tweet at a time, and I want to be able to process each line of those, so I can separate the person who tweeted from the actual tweet. And then I can construct this kind of pair of interaction here. Clearly somebody is retweeting here. So this person is actually retweeting this person here. So here's what we are going to do. So the tweets here is basically my list of tweets here that I read from the file. So this is, if I run this now, then I'm not going to get anything because I'm not printing anything. So now what I want to do, I want to read these tweets one tweet at a time for each tweet in these tweets. And the step after that is to start breaking these tweets into three different components. One is the timestamp, and one is the handle, and one is the actual tweet that may or may not contain that handle. But let me show you something here. The Twitter data is really very noisy, and as you can see here, not everybody writes the whole tweet in one line. You see all these empty spaces is because people push the enter key on their keyboard, so I cannot really guarantee that each line that I'm reading here will constitute a tweet. As you can see clearly here, this tweet here, this guy here, is constructed on three different lines. So here's a really quick and dirty fix for this. I'm only gonna read the tweet, the lines that have three components. Any line that doesn't have the three components, I'm just gonna ignore it, because again, this is not an exercise of how we can read a file. This is an exercise of how we can construct a network, that we don't hard code that network. So this is exactly what I want to show you. So what I want to do now is to actually grab that tweet, and I'm going to split it using the split built-in function on a string, because we understand that this tweet here is a string. So I'm going to split it here using the bar, because I know that my tweets are being split by the pipes right here. So if I split it here, this is going to give me a list of the components that each line contains. But remember, not each line has three components. Like the word hi sir here doesn't have these three components. So I'm going to ignore it. So to ignore it, I'm just going to say if the length of comps is exactly 3, because I know that I'm splitting based on the bars, and I know that my file is structured as the timestamp, the handle, and the actual tweet. If the components here that I'm breaking by the bar is exactly 3, so what I need to do at this point is to grab the handle, okay, And so this is the handle here that I want to grab, and I want to also read the tweet. Okay, so I know that the handle here exists at index 1 because at index 0 there is a timestamp. But I also want to make sure that I'm processing this tweet here. Okay, I'm processing that tweet, and I want to look for, like here, starting with this RT. Excuse me, I'm gonna put my phone on silent again. And now if you take a look at this, this is my tweet, and I really want to be able to process this line here so I can exactly grab this handle here, and I can construct a pair with the person who tweeted. How do we do this? Let me show you. Well, I know for sure now that if I print the component at index 2, this is gonna give me the actual tweet. And if I print it, I can show you exactly that this is what we're looking at. And let me run this like that. All right, one more time. Okay, and as you can see here, we don't have any timestamps. We don't have the people who actually tweeted. We actually have the tweet by itself. All right, so what I need to do now is to actually start even working a little bit more with this component here. I want to work with the tweet so I can grab this handle here. How do I do this? Well, I can split this tweet based on the spaces, the word spaces. Again, this is quick and dirty. We can use some very advanced NLP tools and text mining tools that will do this nicely. But for the time being, I'm not interested in this. I'm just interested in showing you how we can work with the Twitter data and how we can construct a network from that. This is exactly what I wanted to show you. So let's not lose track of that. So now if I split here, this is going to give me all the words in the tweet. And I can now loop over these words and extract the actual word that starts with an @ sign here. So I know that this is exactly the mention that I'm looking for. So I can loop now for each word in words like that. And now I'm going to ask if the word starts with an @ sign like that. What do I need to do? Now, if I know that this word starts with an @ sign, then I know it's the mention that I'm looking for. This is just well-known terminology for Twitter. So what I actually need to do at this point is to grab that word because I know it's the handle or the mention, and I need to connect it with the person who tweeted, which is comps at index 1. Okay, so I need to make a pair of those. So if I do this, comps at index 1 and the actual word like that, this is gonna give me the pair of interaction. So before I go too far, let me do this. Let me tell you that what we need here is a list of interaction. We can say user mentions. So this is the user mentions list, and it's an empty list. And what I need at this point is to grab these pairs, and I want to append them. I want to append each pair that is going to show up. And then this list here is supposed to be giving me, all the list of interaction from all the tweets that I have. If I do this, I'm likely to get what I need. However, the actual Twitter data might be noisy. So let's take a look first before we do anything any further. So, but let me explain. We broke the tweet based on the line based on the bar. Now we're reading each component here. We're reading the second component, which is the actual the component at index 2, which is the third component, right? And we're breaking that tweet by space, if you call it this way without specifying what do you need to split upon, and then you split based on the default, which is a space. Now we take the words and we loop through them, and then we ask if every word, if any word starts with a handle here, then I can construct a pair with that word that becomes that we know already it's a handle, and actually still never forgetting that the comps at 1 at index 1 here is the actual person who tweeted that specific tweet. So we can construct a list of those guys. So if I run this like that, and now let me show you what we need to do. We don't need to actually print the entire list content, but we can print the length of that list. Well, we know here we started the list as an empty one, right? So if I print that list here after running this, and if it's not empty, then it's going to give me a number. So let's run it. It is a number. It has 108 different pairs. Let me do this. Let's just print the pair at index 0, the first pair. Fantastic. As you can see here, we get the handles here, but some handles are ending with this colon here. It seems like somebody wants to grab the attention for somebody else, so they put the colon here. As you can see, I can show you here too. It's really very common. So retweet this person, and then they put a colon after the handle, but clearly the colon here is not part of the handle. How do I get rid of this annoying thing? I tell you how. Well, we can work with the handle here, which happens to be a word. And if we actually do a strip from the right side of the word, because this is the right and this is the left, so we can do right strip like that. And I'm going to strip it based on this colon here. And if I run this one more time, like that, and then I'm gonna print the same thing, and watch here, and let me copy this here like that, so you actually see it after it disappears. And clearly here, as you can see now, is becoming really clean. The underscore, some people actually, this is not noise, some people actually choose to have their handles have these underscore characters. And as you can see, the original one here was with the colon, and the one inside the list now that we're printing is without the colon. Okay, very good. So now let me remind you why we got here. We got here because we created this network object, okay? And this network object, we implemented a function called add edges from, right? And this add edges from, we populated it from a hard-coded list. And let me refresh your memory. And this is the hard-coded list that we used in the previous lecture. But let's go back here. Right now, we did not hard-code anything. We actually got a file that we read, a Twitter file, and then we processed that file. We constructed a list of tuples, and these tuples represent interaction between people in the network, in the Twitter sphere. So how do I populate my network object here? How do I populate a network object with this list here? Well, first of all, we need to construct a network object. Network object. And our network object, but before I do that, let me make sure that I run this into and I put the class definition into memory. Okay, now I have the class definition into memory. Then let's give our network a name, a user mention network, like that. And our network is gonna be undirected, and I am going to pass an empty graph. My network is empty. It doesn't have anything. Remember the implementation here that we created. It takes an edge list if we are adding here using a list. But the constructor here, or the function that does the initialization, it takes a dictionary. And this dictionary is a concrete one. It could be empty, right? And it could be full. Right now, I'm starting with an empty dictionary. So this is supposed to be giving me a network object, and I'm gonna call it user underscore mention network, and this is lowercase. So if I run this from here, I gotten something back. So let me now run the info function, so we see what's inside this graph here. So we have our network object. We are going to call our info function, and we're gonna print it like that. And it tells me that I don't have any nodes in it. Well, I knew that because I already entered an empty dictionary here. And if you don't like this syntax, I'm gonna tell you here. This is empty dictionary, like that. And instead of passing this empty dictionary, you can actually pass a variable here, and this is gonna give us the same effect. And as you can see, the network's still empty. Now, how do we add edges to this network? Okay, well, we have a function here that says add edges from. So we are going to call it add edges from where? The hard-coded list that we used earlier in the previous lecture? This one? Of course not. Well, we could, but that's not the purpose. The purpose here is to actually work with that list that we just constructed here. This is the user mentions that we just constructed from the file that we worked with. So let me go back here, and I'm going to pass this, and this is supposed to be giving me some sort of a dictionary. For the time being, let's actually get the dictionary here. So this is user mention dictionary, because we said that this function is going to return a dictionary, is going to return that self.graph, and the self.graph, we know it's a dictionary. And I will remind you why we actually need this. But for the time being, let's do that. Now I'm going, so I called add edges from, and I passed the user mentions list, right? And now I'm going to call the info function again, and then I want to see what sort of things that I have. Okay, so now we actually created 180, we created a network that is not empty, and now the network has 187 nodes. Okay. Why did I return this? I will tell you why I returned this. Because our network does not have any capabilities of actually generating a visual representation of the info here. We want to see what this network looks like. And this is why we lean over NetworkX. NetworkX can do exactly everything we've done and can visualize, but the reason why we did what we did was because we wanted to understand how things work in the network. But now we understand it, so I'm going to import NetworkX as NX, like that, and I'm going to use the NX handle, and I'm going to call the graph constructor here, like that, and this is going to give me. Actually, I can immediately pass this dictionary like that. And this is gonna return me an object that is fully populated from our network that we created. The reason why we're doing this, again, because remember, this object here is now a fully functioning network, but we cannot visualize it. What we need to do is to pass this dictionary that's coming from this network here to NetworkX. And this is gonna give me a graph, and let's call it NX user mention graph, like that, NX UMG. And if I run it, it didn't take very much. So now let me show you how we can actually draw in the most naive way. Again, I'm not showing you how you can visualize a network, but I'm showing you how you can see it, and you can see the edges that you actually entered based on the list that you harvested from a sample Twitter file. How do I draw this network here? So I'm going to invoke the NetworkX draw function, and the NetworkX takes the graph, and for the time being, I don't wanna see them with labels, because labels are gonna be long. So I'm gonna make it false, like that, and I want to make the node size equals maybe, I don't know, 7, and node color equals red. So if I do this, let's see what's happening. One more time, usually it takes twice. And here is our cute little network. As you can see, there are smaller connections here. So this is really like 5 things, 5 nodes, 5 handles connected with each other. This is also something that is connected to, and there, because my network here, my file is too small. But if I unleash this whole thing from a much bigger file, then I'm gonna find this network much more connected. Let's turn on true so we can see the labels. It's gonna look more busy, and what you can see here are the handles. So I'm just gonna get rid of this again one more time, and I'm gonna make the nodes maybe, I don't know, the size of 15, like that, so you can see it a little bit better. Not exactly, but it's still showing me that some of the interaction that happened between people. And usually one person might actually interact. The reason why we're seeing these kind of interaction from a small file is because we, like I said, sometimes one person mentions a few people. And let me show you from that list here, if we can print that list for a pair in user mentions, and we just gonna print the pair here like that. And let me see, as you can see, there are some repetition here in the pairs, which means that this person interacted with this person, could be in the same tweet or another tweet. And let me also show you here, that's a really nice example here of this person interacting with 4 other people. So this actually explains to us here why we're seeing something like that, because one person here happens to interact with 4 people. And like I said, the more data we have, the more data we read, the more complex this network is gonna look like. I'm actually feeling tempted to see if I have a bigger file here that I can use. And I believe I do. I have a file that has 5,500 lines. So let's do the entire experiment again. And all I'm gonna do is I'm going to change the file name to another file. Okay, and the file is called OK55, and the brilliant environment here immediately recognizes the file by its name. So now if I'm running this, and this might take a little longer than what we saw before. It was actually instantaneous here, and I'm gonna run this, and notice here that we very likely we're gonna have a lot more than just 108. Indeed, because like I said, the file here had 55, So not all of these 55 are pure lines. Maybe lines are broken. That's why we have less than 55. So we have 4,200. That's not bad. And let's try the first record. Okay, so it looks really nice. Let's construct our network implementation graph from the user mentions of the larger size network. Let's do that. Okay, let's do the info here and let's see if this is got something. It's still empty because we created an empty network here. Here we're passing the user mention that has 4252 number of pairs or number of interactions. And let's run the network again. And this is the old run. We are likely to see much more than 187. Exactly. So we have 6,661. So now we're gonna visualize this using NetworkX, like that, and it's actually still working here. As you can see, the star here means that's still working. And I'm going to uncomment this like that, and then we just have to wait for NetworkX. Maybe this is gonna take a little long, but it's actually worth waiting for. I don't know, maybe it's gonna take a couple more minutes or something like that. But as you can see, this is now becoming something real. We started with a very small, very shy Python class. We called it network. And then we basically created a class from a dictionary. And I'm going over the stuff again until we just until I know that my my environment has fully visualized the network. And then we added the set and get functions for that. And all of this is something that you've already seen. And then we also created the info function here, which is really nice. The info function concatenates all these objects, the instance variables, and then print the entire info about the network, except that we have not really added the number of edges here, but it's okay. The idea is to be able to work with the data and work with the object, the network object, and see how the network is constructed. How do we add nodes? How do we remove nodes? If a node is if a network has an edge between two things, how do we add a collective set of nodes that would look really that will populate a network, as opposed to from a dynamic place as we're doing versus a hard-coded list as we've done before. It seems that the visualization is done, and as you can see here, it's a very busy network, a very busy network, which is really great. I'm still also tempted to see if there are people who have mentioned more than one person. Okay, very likely so here. Okay, here this person is the queen or the king of interaction. Look how many people this individual here is interacting with those people, and you see other people are also interacting, and these are three. So this is why you see the network here is much more connected than the previous network that we have seen earlier with a smaller data size. So I think this is a really good demo of what we've done with our network object, and maybe in the next videos we are going to lean a little bit more on the functionality that NetworkX has. Unless we really need to learn something, then we probably just have to dedicate a really nice specific lecture for that alone, so we can start implementing the the actual functionality, whether it was an algorithm like a clustering algorithm, whether it was one of those click detection algorithms, whether there is some sort of a path finding algorithm, all kinds of algorithms. Networks are just wonderful. They are full of mystery and full of excitement. So depending on our appetite here and depending on how much time we have, we can lean a little bit more on NetworkX sometimes, and some other times we are going to implement these algorithms ourselves just to have fun as we implemented the network class by ourselves, and then we populated it from real data. Okay, if you have any questions, write me some comment, shoot me an email, and as always, thanks for watching.